talking about difluoromethane, or CH2F2. So we'll first start by drawing the Lewis structure, and to do so we have to determine the least electronegative element, which is C, and then we write the rest of the elements around it. And then we have to fill up their valence electrons. So hydrogen is a duet, so we're already good there. Fluorine needs an octet, so you draw 6 more electrons around it to fill up its outer shell. And now that we have this, we got to determine if it's correct. So to be able to do so, we write out the number of elements in this compound. So we have 1 carbon, 2 hydrogen, 2 fluorine, and we multiply those numbers by the ideal valence electrons. The ideal number of valence electrons in the elements, so we have 4, 2, and 14 as our total after multiplying, and we add those up together to get 20 valence electrons in total. And we come back to our Lewis structure and we determine if that's right by counting the bonds as 2 electrons, and we count the rest of the outer electrons. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So we know this Lewis structure is correct because we have 20 electrons already, which matches what we calculated for what we're supposed to have. So now to determine the electron pair geometry, we count the number of structural pairs, in which we have 4 elements around carbon and no lone pairs, and that's how we count the structural pairs. So now we know we have 4 structural pairs, which is a tetrahedral electron pair geometry because 4 structural pairs is tetrahedral. And we come over here and we draw it out. So we draw it with fluorine coming towards you and fluorine coming away from you, and we keep hydrogen like this because they're not coming towards you or away from you. This solid wedge means it's coming towards you. This dash wedge means it's going away from you. And to be able to determine the polarity, we have to look and see, well, are all my outer elements or terminal elements the same? And they're not, because we have 2 hydrogen, 2 fluorine. So now we know it's polar, right? So it's polar. And we know the ideal bond angle for all tetrahedral electron pair geometry is 109.5 degrees, right? So now we got to determine the intermolecular forces, in which all compounds have dispersion, and since this is a polar element, we also have dipole-dipole.